Hello there, my little math adventurer. Welcome to our secret playground of numbers. Today, we are going to learn how numbers can draw secret pictures, build shapes, and tell stories. We are going to master steady walking linear lines, uncover the mystery of magical exploding boxes, and use simultaneous maps to hunt down hidden coordinate treasures. Now, you might be looking at math books and thinking, why does this look so complicated? Don't worry, forget about memorizing boring formulas. We are going to use our imagination, building blocks, and toy cars to see exactly how this works. Grab your crayon, and let's dive right into the magic. Imagine you have a magical toy robot. Every time you clap your hands once, the robot takes exactly one step forward. Let's track him together. 0 claps equals 0 steps forward. 1 claps equals 1 steps forward. 2 claps equals 2 steps forward. 3 claps equals 3 steps forward. Now, let's play connect the dots with his footsteps on a grid map. Look at that. Because our robot grows at a perfectly steady, unchanging rate, his footsteps form a perfectly straight line. In the math world, we call this a linear equation. You might ask, why such a weird name? Well, look closely at the word linear. Do you see it? It has the word line hidden right inside it. Because the growth is always fair and steady. It can never bend. It stays straight forever. But wait, what if the robot walks backward? If you clap and the robot takes steps backward, the line just slopes downward instead. And what if you tell the robot, hey, stay at step 5 and don't you dare move no matter how much I clap? Single quote question mark. Then all his dots stack on top of each other, creating a straight horizontal or vertical wall. Because all of these are perfectly straight lines. They are all part of the happy linear family. Now, let's change the rules of the game. This time, our robot gets a superpower. Whenever you give him a number, he doesn't just copy it. He builds a perfect square box out of that number and counts the total blocks inside. This is called squaring a number. And we write it with a tiny, floating 2 at the top like this. X squared. If you choose 1, he builds a 1 by 1 box. Total blocks equals 1. If you choose 2, he builds a 2 by 2 box. Total blocks equals 4. If you choose 3, he builds a 3 by 3 box. Total blocks equals 9. Now look at that right side. You might be wondering, wait, why is it curving? And where is the U shape? I only see half a U going up to the right. Single quote. Here is where the magic happens. Let's see what happens when we move to the left into negative numbers. If you give the robot a -2, he has to build a -2 by -2 box. Now, here is a secret rule of the math universe. Two negative signs multiplying always smash together to turn into a positive. So -2 times -2 gives you a positive height of 4. Because moving 2 steps right gives a height of 4. And moving 2 steps left also gives a height of 4. The left side completely mirrors the right side. Suddenly, the two halves join together to make a giant, smooth smile. This perfect U shape is called a parabola. And any equation with a power of exactly 2 as its biggest term is a quadratic equation. You might be thinking right now, okay, teacher, I get it. So does that mean anything with an even power is a quadratic? And anything with an odd power is a linear? It is a brilliant guess. But the math world has a very strict naming system. Let's look at the secret code of powers to see why. The even power family. Your intuition about the shapes is 100% correct. Because multiplying an even number of negative signs always turns positive. Both arms of these graphs will always point up together like a U shape. But only x squared gets the special title quadratic. What about x to the 4th? It is called a quartic. Because the numbers explode way faster. The bottom of its U shape gets squished flat like a soup bowl. And its sides shoot straight up like rocket walls. So they look similar. But they aren't the same. The odd power family makes an S shape. Why? Because a negative multiplied an odd number of times stays negative. So the right arm shoots up to the sky. But the left arm plummets straight down to the basement. X cubed is the leader here. Called a cubic equation. Now look at your list. 6 and 9. Why don't they fit? Remember our even rule. Because x to the 6th has an even power. It actually tricks you and makes a U shape. X to the 9th has an odd power. So it makes the S shape. And why can't any of these be called linear? Because a linear equation is a minimalist. It has no powers at all. The absolute second you add a power, the growth accelerates. And a straight line instantly bends. Imagine you and your best friend are playing hide and seek in a giant park, and you want to find a secret treasure box. If I give you just one clue, the treasure is hidden somewhere along the straight line equation y equals x plus 2. You are going to be so frustrated. That line goes on forever. The treasure could be at the start, middle, or a million miles away. One equation leaves you with too many choices. To find the exact spot, you need a second clue at the exact same time. A simultaneous equation is simply when we look at two different math clues at the same time to see where their lines collide on the map. The word simultaneous just means happening at once. The intersection point where the lines cross is the only place where both clues are happy and true. Let's break this specific intersection down step by step using a simple layout to see exactly why they cross at just one point. Step 1. Track the first line. Y equals x plus 2. This line starts at 2 on the vertical y-axis and climbs steadily upward. Every time you take one step to the right, you must take one step up. At x equals 0, the height is 2. At x equals 1, the height is 3. And at x equals 2, the height is 4. Step 2. Track the second line. Y equals minus x plus 4. The negative sign in front of the x means this line goes downward instead of upward. It starts higher up at 4 on the vertical axis. And every step right means one step down. At x equals 0, the height is 4. At x equals 1, the height is 3. And at x equals 2, the height is 2. Step 3. Find the collision. Look closely at the coordinates we just calculated for both lines. At x equals 1, line 1 reaches a height of 3. Line 2 drops down to a height of 3. Because both lines occupy the exact same grid coordinate 1, 3 at the exact same moment. That is their intersection point. When you solve a simultaneous equation on paper, you are just setting the two heights equal to each other to find where they match. Since both equal y, you can write x plus 2 equals minus x plus 4. Add x to both sides to get 2x plus 2 equals 4. Subtract 2 from both sides to reveal 2x equals 2. Divide by 2, leaving you with x equals 1. Once you know x equals 1, you plug it back into either equation to get your final meeting point height of 3, cleanly pinpointing our coordinate at 1, 3. What an incredible journey through our secret playground of numbers. Let's look back at the grand map of everything we discovered today. First, we tracked our walking robot and discovered linear equations. Because the growth is always perfectly steady, it creates a clean, straight line that never bends. Next, we gave the robot a squaring superpower to build exploding boxes, uncovering quadratic equations. We learned that two negatives multiply to make a positive height, joining both sides into a beautiful U-shaped parabola. Finally, we combined our clues to play the ultimate game of hide and seek with simultaneous equations. We proved that looking at two math clues at the exact same time reveals the single magical collision point where the treasure is hidden. See, you didn't need to memorize a single boring formula to see the deep structure of the math universe. Keep exploring. Use your imagination. And I will see you next time, my brilliant math adventurer.